Hi everyone, welcome back. We're going to continue our conversation on terrestrial planets, talking about our home Earth. So, this is, of course, the third planet from the Sun, and it is at a distance of 1 astronomical unit, like I said before, or 93 million miles, or 150 million kilometers, whatever units you want to use. Typically, in astronomy, we will use astronomical units. Okay. All right, my dog is having a fit. Um, it's also the largest of the terrestrial planets, or the fifth largest in the solar system. It's just a little bigger than Venus. Like I said, Venus and Earth are very similar in size, but Earth is just a bit bigger. It rotates once every about a day, as we know, or about 24 hours, and orbits the sun in 1 year, or about 365 days. It is, of course, a rocky planet with a solid surface, like we know, has many canyons, mountains, plains, etc. We have a lot of geologic activity, sorry. Um, we also know that we have liquid water on the surface, and it's known to be the only one with liquid water. Of course, we saw that there is ice on other planets, and we'll see that again, but it's the only one with liquid water as we know it on the surface. Um, I have here what the atmosphere is made of. It's, like I said before, mostly nitrogen, some oxygen, and then 1% other elements. Um, and this protects the planet from incoming meteoroids. Like I said before, that we do have a pretty strong global magnetic field, and we can see that in this image here. So the solar wind comes towards us from the sun, and this magnetic field will kind of deflect it. So it'll just kind of create like a shield around us, like you can see in this image. Obviously, we can't see that with our eyes, but we can see it with some different technology, and we see this magnetic field that has formed around the Earth and acts as like I said, a shield from this solar wind that's incoming. Okay. We also know that we only have one moon. We don't have two. We just see one at night. And we don't have any rings. We would see that. And of course, life has flourished here. We have all kinds of life. Okay, I wanted to talk about the interior structure of Earth, just to give us a little bit of an idea. So, we, of course, have three major layers of the Earth, but we have the crust, which is what we live on. We have the mantle, which is a big bulk inside. We have an outer core, and we have an inner core. So, the outer and inner cores, it used to be just one thing. We just said the core, but we actually have a division between the two now. And this separation is a very good example of differentiation. Okay, so we have this differentiation due to the densities of this material. So, on the crust, or the crust, we have two different types. We have oceanic and we have continental. So the oceanic crust covers about 55% of the surface and is typically about 6 kilometers thick, composed of volcanic rock called basalt. Okay, so that's the typical oceanic crust that we see. Then we have the continental crust, which covers the other 45% of the surface. It can be anywhere from 20 to about 70 kilometers thick, and it's composed of another kind of volcanic rock called granite. And these, of course, are more general, but we see different types of rock on the surface. Um, and in the oceans, we'll see different types of rock, but this is generally what the crust is made of. Okay, so we see basalt and we see granite. Okay, then we have the mantle. Now, the mantle is the largest part of Earth. It stretches from the base of the crust all the way down to about 2,900 kilometers. Okay, and it has a density of about 3.5 grams per centimeter cubed to about 5 grams per centimeter cubed. Okay, so that's what I was talking about densities earlier, that densities were some mass per volume. Okay, so this mantle is more dense than the crust, so it's deeper into the center of Earth. Okay. Then we have the core, which is going to be even denser and more metallic or made of metals. The diameter approximately of the core is about 7,000 kilometers, which is larger than Mercury. And we have two sections. So like I said, we have an inner core and we have an outer core. The outer core is liquid, the inner core is solid, and made out of roughly the same material, iron and nickel, or iron or nickel. So the outer core is liquid, iron, and nickel. The inner core is, I believe it's solid iron. It might be nickel as well. Okay, so this is the basic structure of our Earth. Okay, now I wanted to talk about our moon. So the Earth's moon is at a distance of about 239,000 miles, and that is a natural satellite. So a natural satellite is something that orbits a planet that is naturally there. So it's not something that was human-made or human-placed there, okay? It is tidally locked with Earth, so the rotations are in sync, the rotation and the orbit, and that's why we see one side of the moon. It has a solid rocky surface that is cratered from impacts of asteroids, meteorites, and comets. It has a very thin atmosphere called an exosphere. It can't support life as we know it, and we have more than 105 robotic spacecraft have been launched to explore the moon. And it's the only object that has been visited by humans, the Apollo missions. Okay, so that's a brief overview of the moon. We did talk about moon phases and so forth beforehand. So we just kind of wanted to talk about the actual surface and how it's formed. So one thing that I wanted to point out is the surface of the moon and what it looks like. So we have lunar highlands, so it would be like mountains. Then we have lunar maria, which are flat plains of basaltic lava, which is about 17% of the moon's surface. So we can see here we have a large lunar rock and a person that's probably taking samples of it. Then we can see some craters here, and these would be the highlands. We have a lot of higher elevation, um, higher elevation land. And then we have the lunar maria, which is a lot of the flat plains. Okay. So I wanted to quickly talk about craters. So I mentioned them before, a little bit how they form, but here is a very good picture of it. So something like an asteroid or a meteorite or a meteor will come and hit the surface of the planet, and the impact will create shock waves and then move material out of that and create these little crests, you could say, these little like ridges here, about right there. And the foreign material that was that impacted that planet or other object like the moon will cover that surface, and it'll create these ridge-like things. So we have a flat area with these ridges on the side. Okay, and again, this is because of that foreign material that's filling in um, that impact spot. Okay, so we can see the difference between a terrestrial volcano and a impact crater. So the terrestrial volcano will have some sort of elevation to it. It won't be very deep versus the lunar impact. It won't necessarily be at a high elevation or have some big elevation change like this guy does, right? This is pretty shallow, basically like one elevation level, um, and then it'll have these little ridge-like things. Okay, and here's a couple of real-life images. This is on the surface of the moon, so we can see this deeper-looking spot, and we have this ridge, this area here that looks like it's gaining elevation. It's getting taller, right? And then over here, this is on Earth. You can see there's like roads in a little town here or something, buildings maybe. And we have this impact. And I believe this was in Arizona, if I'm not mistaken. It is in the textbook, I believe. So we see this huge impact, and we can see the sides, these ridges that were lifted up. Or filled in just because of that material. So these are very similar. So things that we see on other planets or moons, we can sometimes see on Earth. So we can kind of get, firsthand descriptions rather than having to travel way over there to figure out what's going on. All right, and then quickly I'm going to talk about the formation of the moon. So there were three main early hypotheses about this. We have the fission theory, which was that the moon was once part of Earth, but then somehow separated early in their history. Seems a little bit unlikely, I would say, just because of gravity. If something is together, they want to stick together. Maybe separation by another impact to split them up, maybe. Then we have the sister theory, which was that the moon formed together with, but independent of Earth, as we believe many other planets of the outer planets formed, many other moons, I should say. And then we have the capture theory, which is that the moon formed elsewhere in the solar system and then was captured by Earth. Um, sort of unlikely due to the size comparison of the moon and the Earth. Then we have the giant impact hypothesis, which is the current hypothesis of the formation of the moon, current accepted one, I should say, which is that the moon formed when an object collided into early Earth. So I want to say Theia. I think that's the name of the early moon, I should say. The idea is that this object, it's about the size of Mars, impacted Earth, and the debris kind of circled around Earth for a little bit due to that collision, and then the debris eventually stuck together due to gravity, and it created the moon. So this is a really good depiction of that process of what we believe now to have happened. Okay, so I'm going to pause here. That was a lot of information about Earth and the moon, and we are going to continue our discussion talking about Mars in the next lecture.